All right, let's continue. Okay, one linear and one quadratic. We have seen, let's see. Okay, let's say y equals x minus 1, y equals x squared minus 4x minus 1. So we learned of a few methods to solving two linears. What are some of the methods that we have? Substitution, yeah. What else? Elimination, yeah. Yeah? Do you want to come in? Maybe I did that on purpose.
What?
Maybe I did that on purpose.
Look what I'm doing to your class though. Sorry. There's Megan.
Grand. Was somebody using the room this evening? That was just left at the front. I didn't know if there was something going on.
Oh, maybe last evening or something.
Evening class then, yeah.
Thanks so much. Sorry guys.
Okay, so what were we saying? Elimination, substitution, a couple more methods we had. Gaussian and one more? Graph, yeah. For these problems, there's only one method you can use, which is, yeah, what is it? Substitution, yeah. The only way to solve these types of problems is by subbing the linear part into the quadratic part. Now, before I continue, what's different, another difference here is that the number of answers you could have. So previously, when we had two linears, we'd have one answer. Yeah? But now we have a quadratic and a linear. So how many answers could we have? We could have two. Or we could have one. Or 0. So we don't know until we start. Let's see what happens here. Subbing this in, I get x minus 1 equals x squared minus 4x minus 1. Yeah? That's x squared minus 5x equals 0. Yeah? So that's x times x minus 5 equals 0. Great, so I have two values of x. What are they? 0. Who the heck is calling me? I'll answer later. Right, 0 or the other value? 5. Okay. Are they really? Okay. 0. And if I put in 0, what do I get for y? Minus 1. And if I put 5 in? 4. So the picture looks roughly something like this. 0 minus 1. And then 5, 4. So you had a quadratic that passed through those 2 points, and the linear passes through those 2 points. So this is what the answer looks like. It's not so difficult, right? We'll do a few more examples. You can write this down as our first example. Okay, you got that copied down? Yeah? Let's have a look. Another example. Can I scroll down? Now, I'll give you a moment to try and get the answer here. I don't think it'll take you too long. So tell me where these two meet. Okay, we got the answer? Answer or answers? Answers, yeah. Answer, yeah. So for this one here, we have only one solution, meaning the line and the quadratic curve meet only once. Does anybody know the name of that situation? What do you call a line that meets a curve once and once only? Tangent, very good, yeah, tangent. Oh, so what do you call it when it meets it? Huh? What? What do you call it when it meets twice? No. Tangent we said was once. Bitangent? Antitangent? Untangent? Cotangent? Retangent? What? Not bitangent, no. Anybody know? Flexitangent? No? Anybody? No? When the line meets the curve twice, it's called a chord. Did you know it? Yes? Okay. And once is a tangent. Okay? Right, so let's have a quick look at this one. 3x minus 11 equals 3x squared minus 3x minus 8. So you have 3x squared minus 6x. What's that? Plus 3, is it? Divide by the 3. And this has only one solution. X is 1. And you can see when x is 1, y needs to be minus 8, is it? So what does the picture look like here? Well, very roughly speaking, it will look something like this. 1 and minus 8 will be like here. So the line is going like this, and the curve meets it only once here like that. So that's the type of picture you have there. Okay. Right, now those examples weren't so difficult, but we want to do a couple of really tough ones now. Let's have a look. Can I scroll down? Yeah. So something much tougher now. 2x minus 11y plus 54 equals 0. And then 4x squared plus xy minus 5y squared equals 0. Now, why is this much tougher? What's the difficulty here? There's two problems. We have a y squared. That's definitely going to make it tougher. What else is the problem? Yeah, the first equation is not so convenient, is it? We have to do something to it first. Yeah, make y the subject. Also, another problem is this equation contains xy, whereas previously we didn't. We had only x and x squared. So we can actually make x or y the subject, but let's just stick with what we were doing before and make y the subject. So here, you could say 2x plus 54 over 11 equals y. Are we okay with that? You take the 11y to the right and divide by 11. Yeah? Is that okay? And then you can sub that in. So now you get 4x squared plus xy, which is 2x plus 54 over 11, minus 5y, which is 2x plus 54 over 11 squared, equals 0. Okay? So this becomes 4x squared plus 2x squared plus 54x over 11 minus, oh actually that 5 is on the top still, 11 squared is 121, and if I expand this I get 4x squared plus 216x plus whatever 54 squared is. What is 54? 2916. But I'm not actually finished because I need to multiply in the 5, don't I? It's a bit of a pain. 4x squared plus 2x squared plus 54x over 11 minus over 121 equals 0. 20x squared plus 1000, what is it? 1080. This might, just be careful, this minus is still on the outside, okay? Yeah, I'm going to leave the minus out for just a moment. So that's kind of out of the fraction, alright? Plus 1080 x plus, what's the last one, please? 14,580. Okay. Now don't worry, it'll work out. To make our lives a little easier, I'll do a multiplication by 121. So 121 times 4 is 484. Is that right? 484. Right? Yeah. Now, when this multiplies by 121, what happens? 11 goes into 121 11 times. And 11 multiplies 2 to make 22. And 11 multiplies 54 to make 594x. And what's nice is they cancel in this one. And I'll put the minus in now. Now, at least it's a quadratic with big numbers. How many x squareds do I have? 484 plus 22 minus 20.
It's supposed to be minus 145.
Thank you, minus there, thank you. 486?
486, yeah.
X squared. Now the x is 594 minus 1080. So that's minus 486x minus 14580. So what do you want to bet that I made this question so that you can divide by 486? Yeah? Which one? Oh yeah, but then there's a minus 20. Yeah. Oh no, I'd be very sad if that wasn't 486 as well, because that would make our lives much harder, wouldn't it? If we divide by 486, I'll get x squared minus x plus what, 29?
Minus
30, okay. Equals 0. Now that's not so bad to solve now, is it? What do we get here? 6 and 5, huh? How does that seem? X minus 6 and x plus 5 equals 0.
Yes.
That's right.
Yes.
Yeah. So look, you have two answers for x. X could either be 6 or minus 5. And then how do you get the y values? Well, you sub it into this one here. It would be quite nice, wouldn't it? So if I put in 6, 2 times 6 is 12. 12, that's 72, 6. And then if we put in minus 5, that's minus 10, 44, is it? Okay. No need to draw the graph for this one. It's not something on the course. Yeah. So, much harder than the previous two examples, right? But the good news is, you know, it's 99% likely that the example you'll get, okay, maybe not 99%, 95% likely that the example you'll get will be like the previous two. But there's a small chance you could get something really tough like this one here. Okay? But I think the only reason it was really tough was because it's just really messy. But it's still the same method, which is substitution. It's just messy. I think a lot of students would not think maybe to multiply by 121 and just carry the fractions down. Asking for trouble, something could easily go wrong. Right, which ones will we practice? Yeah, good. Okay. I'll give you 2 easy and 2 hard. One H, 1 I, 2 F, and 2 G. There we go. And if you don't get them done now, you'll have to finish them at home. So again, I'll just give you about 5 or so minutes. Try and get those 4 done. Ray is still sick, isn't he? He must be. He wasn't here yesterday. Ray? He was? Are you sure? I don't remember. Are you sure Ray was here yesterday? For sure? Yeah,
because I remember like going outside and like hello.
Okay. There was one person absent yesterday. It wasn't Ray?
No, it was Hussein.
Okay. For sure?
Yes.
And Ray was there?
Yes.
Okay. Oh, that's right. I remember now. Yeah. Okay. All right. So, well, anyways, no matter, Ray's not here this morning. That's for sure. Okay. Okay. Diana? Oh, there you are. Mohammed Omar? Oh, there you are. Hussein? Is not... Oh, he is, okay. Oh, don't look now, here comes Colin.
He's here, but I think he'll.
Oh, you're escorting the student, is it? Okay. Sorry, Hussein is here, you've just gone out for the toilet, yeah, okay.
Yeah.